Hello dear students, today I will discuss about the symmetry of circuit, means or it is called also the symmetry rules, by which we can find out the value of equivalent resistance of this type of complicated circuit. So how to solve the equivalent resistance in between complicated circuit? To solve this type of circuit, we have to find the symmetry. What is the meaning of symmetry? Choose one line across the resistances or across the points, then we get the symmetry. Means if we imagine a line across this resistance, then this side will be R by 2 because we are dividing it, so this side will be R by 2. Same case will happen over here, R by 2, now R by 2. Now look, we are getting the symmetry on each side, this side and this side also. Now what will we do? Imagine one line is there. So if we find equivalent resistance in between A and C, and then we will multiply by 2, then easily we will get the equivalent resistance in between A and B. So to do, I am drawing the simplified circuit. Suppose this point is A. Now see, this is R by 2, obviously this is R by 2, this side only I am drawing, and this is the point C. And from here one resistance is connected, which is R. This is also R, and this resistance also R. Same case will happen over here. Means this is R, and here this will be R by 2, and here one more R is there. Now I will find the equivalent resistance in between A and C. Look, R by 2 are connected in parallel, so total resistance will be R by 2 into R divided by R plus R by 2. So it will come R square by 2. Here it is 3R by 2. So 2 cancel. This will be R by 3. So here we are getting the equivalent R by 3. Now see, R and R by 3, it is series. It is in series. So this will be 4R by 3. 4R by 3. Okay. So same case will come over here. This now first time it will come R by 3. Next R and R by 3 series, so it will come 4R by 3. Look, now this 4R by 3, R and 4R by 3, these are connected in parallel. So 1 by R dash will be 1 by 4R by 3, means this will be 3 by 4R plus 1 by R plus 3 by 4R. So 4R is the LCM, and 3 plus 4 plus 3 means 10 by 4R, and then R dash will be 4R by 10. This R dash is the equivalent resistance in between A and C. So total R will be 2 into 4R by 10. Why? See, this total R will be 2 into 4R by 10. Why? Because we got up to A and C, it is 4R by 10. So this part left in between C and B, this is also 4R by 10. So that's why I have multiplied by 2, which will come, the equivalent will come 4R divided by 5. This is the value of R. Okay, clear? This is the equivalent resistance in between A and B. Now, in the second problem, how to find the equivalent resistance in between A and B. To solve this type of circuit, I will choose one line across this resistance. Okay, by which this will be R by 2 and this side will be R by 2. Now see, we are getting the symmetry of this part and this part in both sides also, so I can choose it. Now see, the simplified circuit I am drawing. Suppose this point is E, this is R, this will be R. Now one line is there, and from here this will be R by 2. Clear? Now from here this is R, and this was R, and this line means this will be okay. Suppose give this point C, so this will be C. Clear up to this? Okay. Now see, we will find the equivalent resistance in between A and C, then multiply by 2. Look, this R and R by 2 is connected in parallel, so this will be R into R by 2 by R plus R by 2, this will come R by 3. So this will be R by 3. See, R into R by 2 divided by R plus R by 2. this will come r square by 2. This is 3r by 2. 2 cancel, so r by 3. Okay, so r by 3. Okay. Now this r by 3 and r, these are also parallel. Means I am calculating about this point, across this point. Okay, so r by 3 into r divided by r plus r by 3, it will come r square by 3 divided by 4r by 3. 3 cancel, so r by 4. So across this terminal we are getting r by 4. Clear? R and r by 4, they are series. Now r plus r by 4, this will be 5r by 4. So we are getting 5r by 4. Okay, now see 5r by 4 and r, these are parallel. So this will be 5r by 4 into r divided by 5r by 4 plus r. What will be the value? Now see, the value is near about 5r square by 4 divided by 5r plus 4r, means 9r by 4. 4 cancel, this will be 5r divided by 9. See here, we are getting that 5r by 9 across A and C. So the total r will be 5r by 9 into 2, which will be 10r divided by 9. This is the equivalent resistance in between A and B. Clear? See, in third problem, how to find the equivalent resistance in between A and B. Look, here I will imagine one line across A and B by which I can fold the circuit. See, if I fold it, then this point, suppose this is P, this will fit with this point. Mean this point will also be P. Okay, so in the similar case, if this point is Q, so this point will also be Q. See, I am folding it. Across A and B I am folding it. So obviously this point will fit with this point. That's why I have written this point is P. And here it is M, so this point will also be M. Look, here this resistance is connected in between A and Q. This resistance is connected in between A and Q. See what happens. In this case, R and R. Suppose this is A and Q. Both are connected in between A and Q. That's why we can say these two resistances are connected in parallel. So here this will be parallel, means R by 2 will come. And here C, suppose this is C. You give CQ, CQ. These are parallel. This is also R by 2. Again CM, CM. This is R by 2. QP, QP. And this is QP. Okay. R by 2. PM, PM. This is also R by 2. And one more left. MB, MB. This is also R by 2. Look. Now if we calculate the resistances, then net resistances, then we will get the equivalent resistance in between A and B. So try to solve. See, here we will get the equivalent. This R by 2, this R by 2 series, this R by 2, this R by 2 series. They are parallel. Means here we will get R, here we will get R. So net will come R, R and R, means R by 2. So the net resistance will be R by 2. Here I am getting R by 2. This point is C. Okay? Because across this, which point I am calculating? Across this point. So we get in between Q and M. No, this is not the C. We are getting the equivalent in between Q and M. This point is Q, this point is M. So A, Q, M, B. A, Q, M, this is B. Okay? Now this is also R by 2 was there. Clear? So it will come total R equals to 3R by 2. R by 2 plus R by 2 plus R by 2, it will come 3R by 2. Clear? This is how you can solve the equivalent resistance of that type of complicated circuit. One new problem I took. Here also you have to calculate the equivalent resistance in between A and B. Here two processes I will show. Look, first method. First method is divided into two parts by which we can get the symmetry. See, if we divide it, this side will be R by 2, this side will be R by 2. So we are getting the symmetry of the circuit. So if we find the equivalent resistance, suppose this is C, equivalent resistance in between A and C, then we can easily find out the equivalent resistance in between A and B by multiplying by 2. So here the equivalent will be between A and C. See, this is R, but this side will be how much? R by 2, and here is one line, this is R. Okay. Now this R by 2 are, they are parallel. So this will be R by 2 into that we have calculated, this will be R by 3. Okay. Now this R and R by 3 will come 4R by 3. They are in series. Now this 4R by 3 and R, that calculated. So 4R by 3 into R divided by R plus 4R by 3, which we will get 4R square by 3 divided by 7R by 3. 3 cancel, we are getting 4R by 7. So total, this will be R test, and total R will be 2 into 4R by 7, which we will get 8R by 7. Now see, in the another method also I will show this 8R by 7 will come. Now the answer came 8R by 7. Now I will use the another method by which the result will come also 8R by 7. Look, second method. So in second method, what will we choose? This is A. Suppose the current is flowing through, from A is I. So it is getting two paths. So here this will be suppose I1 and this is I2. So as it is I2 and this is I1, so when it will come here, suppose this is D and E I am giving. So here also this I1 is getting two paths. Suppose here I3 is flowing, and here will be how much? This current will be I1 minus I3, correct? Okay. Now look, here as the resistance is R and here the resistance is R also. So obviously as the current flows through R is I1, so here also the I1 will come. I1 will come because the resistances are same. Clear? Now look, here this point is E I have given. So I3 is going, here is also I3 will pass. Why? Because look, if we apply the Kirchhoff's law over here, we will get the current, total current is 0. How? This is incoming, this is outgoing. So I1 minus I3 plus, this is total plus, I1 is outgoing, so this will be minus. Okay, so total will be 0. See how much it is coming. I1 cancel, means I minus I3 is coming. Means obviously this point, this inward current or incoming current will be I1, by which we get the net I will be 0. Clear? So here this net I will be 0, as if we get this current is I3. So if the current is, if here this current is I3, then we can neglect this junction also. Means this junction is like that, because only the I3 is coming and I3 is going, means no current is flowing through this junction, so we can neglect it. So if the I2 is flowing over here, and there will be I2 also, by which we will get the net current. See, net current how much? I equals to I1 plus I2. So the net current emerging from B will be also I1 plus I2. This will be I1 plus I2, means this current. Okay, so how we will get the value of I1 plus I2? If this is I1 and this is I2. Okay, now look, now easily we can find out the equivalent resistance. See, this was R, so clearly I am writing, the answer was 8R by 7. Okay, now look, there is no connection, so we can neglect it. So R, now find out the equivalent resistance in between B and D. Look, R series, they are parallel. R series means 2R, they are parallel with R, 2R by R plus 2R. So this will be 2R square by 3R, means 2 by 3R in between D and E. D and E. Okay. Now these are 2R by 3 and R series. So R plus 2R by 3 plus R. This will be 3R plus 2R plus 3R, means 8R by 3. in between which one? In between this one and on another, these 2 are also left. So this 8R by 3 and 2R, they are parallel. So net R will be 8R by 3 into 2R divided by 2R plus 8R by 3. Look, 8 into 2, 16R divided by 3 divided by 3 into 2, 6 plus 8, 14. So 14R by 3, 3 cancel, we are getting, this is R square. So 16R divided by 14. So answer was how much? 8R divided by 7. See, 2, 8, 2, 7. So answer is 8R by 7. Clear? Okay. Here also I am getting the value of 8R by 7 ohm. And this formula, by this method of symmetry also we can find out the value of 8R by 7. Okay, by this method or that method also you can apply.